I'm the chief scientist at Motif Analytics, and I'm going to tell a story about something that we've been working on, and basically my ex post rationalization for why what we did made sense. And I hope it sort of portrays a lesson that I've learned, and that actually what we're doing does make sense, but maybe it doesn't, and maybe I'm just making up some excuses. So this is a David Byrne quote that I've adapted. I joined Motif in July. We started working on sequence analytics, and I found myself at this beautiful startup with all these smart people, and we wrote a query language, and that's what we've been working on for the last few months. And I'm not ready to show it to you today, and this isn't going to be a Motif commercial as much as I would love to do that. But it is a little bit questionable, should you write a query language? And everyone loves SQL. And I know a lot of people don't like new query languages. This is somebody that I really respect a lot, Eric Bernardson, saying, I don't really like software that invents its own query language. And we would joke at the company that maybe our product is dead on arrival because no one's going to want to learn a new thing. And smart kids say no to DSLs, which is I just love this graphic that he included. And once you decide to go down this road, every time you make a bad choice, it becomes harder to make a good one. And so you can end up in a bad state if you make a bad choice at the very beginning of your project. And so new query language may be a terrible idea. I'm going to try to justify to you why we might need that, and then why you also might need to be thinking about different kinds of query languages. So here's the setup for Motif, and I'm not going to belabor it too much, but roughly we think about user behavior on a website or an app as a sequence of events that occur that have a user ID, a timestamp, an event name, possibly some other metadata. And the kinds of questions that we like to ask are what happens after a user does something, what happens before something happens to a user, and then what happens between. These are what we call sequential questions. They have a certain flavor to them. And so we could lay this out left to right on a timeline and say okay, this is a kind of golden path for a user of a video streaming service. So they start at a search page, they see some search results, they click on that, they preview the video, start watching, and finish watching. And a very natural set of questions to ask are things like, how many users make it through this process? Are they getting stuck at various times? And where do they get stuck? And where do they kind of stop using your site? Do they take detours into doing something else that isn't on this happy path? And does it depend on things that happen earlier in the sequence in various ways, say maybe what device they're using or what kind of connection that they're on? And is it something that we could possibly fix? And so this is a space of questions that's really rich and important for people. And I think we all are kind of interested in answering questions like these in our jobs often. One person in particular, Tej Murphy, who's a friend, and he gave me permission to share some of his slides from his Snowflake talk, spent a long time thinking about this and working on it. So he has this talk, Funnel Analysis in SQL from Start to Finish. And I didn't actually get to see the talk in person, so I can't claim it was a great talk. I'm sure it was. But the slides are great and they're very informative. And he basically spent a long time prototyping 3 ideas, and then there's a 4th one that I won't include because it's inconvenient for my point. But he's got 3 approaches to solving this problem using SQL. And so the idea is we want to count how many users make it from A to B to C to D, possibly with time gaps in between that we want to constrain, and that we want to kind of figure out how to analyze this funnel. And there's 3 approaches to it. There's a join approach, a window function approach, and a regular expressions approach. And they have different characteristics. Max K is one of them, which is this is how many steps that you're actually capable of counting in a reasonable amount of time. And so we can see for join, it's a small number. Then there's performance, which is how much data we're able to process. And then very importantly, there's this column on ease of use. And Tej very conveniently has this star rating system. I don't know if it's out of 5 stars or out of 3. And perhaps he said this in the talk, but this is kind of roughly what we think about a lot as analysts is how do we solve a problem in SQL, and then what kind of characteristics will that solution have? So we can think about what are we trying to do when we do sequence analytics in SQL, and why might this be a little bit challenging to think about how to do? Well, the left join approach is taking a table and doing joins onto the same table, and you could even do a recursive join if you wanted to, and create a bunch of columns for all the different sequence elements. And this is what Edgar Cod, the inventor of the relational model, would want you to do, because he doesn't want you to add window functions or denormalize your data in any way. But this is very not performant because you have to do joins, and for some reason databases are bad at doing many joins, despite that that's what they're designed for. You could also use window functions. So the predicate now would, instead of being across columns, like in these purple boxes, it would be across rows. And this is really kind of getting at the heart of what we're trying to do here, is like apply conditions or predicates that span multiple rows in the data or multiple relations. And so we partition and order the data, and then we can do this window function approach. Or we could denormalize the data and create a special column that has an aggregate type. And then that aggregate type, we could write like UDFs or something like that to apply to that. And in Teej's approach, it's like, oh, we'll just use regular expressions. We'll construct strings and use regular expressions. And that's another kind of like way that we might think about solving this problem. At the end of his approach, he sort of like, motivates these things plus a fourth approach. And then several months later, I saw him tweet this last night. This is like, shows how late I was working on my slides. I never want to write a funnel in SQL ever again. So this is the person that I know who spent the most time working on funnels in SQL. Maybe it's because he spent so much time on it, but he knows the most about how to do it and how it could be done. And he doesn't think it's particularly fun to do or usable. So I think they want to get to the point here of like, just because something is possible to do in a query language or in any language for that matter, it doesn't mean that it's likely that people will do it. And this is an important point. It's just not about like whether something is capable of doing something. It's about whether a user would practically do something. And we have Tej Murphy, the expert on funnel analysis, telling us that he never wants to do it again. It's a bad sign for whether people will be doing funnel analysis in their jobs. And I want to make the point that it's not the relational model that's the problem here. It's a fully expressive model. I mean, like, Edgar Cod is right. Like, relational model can solve this problem. And the events are perfectly well represented as a relation. So it's very reasonable to think about, like, why should SQL not be capable of doing this very easily? And like, what should we be doing instead? And another important point to make here is that this is an analysis we're not going to probably write one time. There's this illusion that like, oh, we write this query and walk away from it. But actually, we all know that when we write a query that we end up tweaking it and making changes, and that the funnel might change or be more complicated than we first acknowledged, and that this is an iterative process. And so we're going to need to solve this in maybe a different way. And I want to be open-minded about that. And that's where that foolish consistency is the hobgoblin of little minds. So like, this is the only tool I'm allowed to use, is the one that I already have, is a little bit of a foolish consistency. So we have three possible things that we really want to, boxes that we want to tick. We want to have completeness, which means like any possible funnel question could be answered. And it might be possible that some things are not possible in SQL. I don't want to make that claim because I know someone will immediately rebut it. So I'm not going to say that there's a thing that you can't do in SQL, or unless I want someone to actually solve that problem. But I do think that expressiveness is a really important criterion here. It's like, even if it were possible to do an analysis, do I need an expert to do it? Could I do it in a reasonable amount of time? And then there's this like efficiency question, which Tej is very concerned with, is like, could it be done quickly or at all on the large amount of data that we might have? So we want to kind of like tick these three boxes if we can. So let's think like abstractly about what are we really trying to do when we design this procedure. It's like we have input data, and then our job is to fill this hole, the dashed line here, and create some output data that is the answer to our question. So I break this down into three phases. There's this expressing phase, where I go from intention to query syntax, and you can see all the joins that I have to do to get it to work. And then the database system will execute that query, produce a result, and then I will look at the feedback and like verify that it is complete. And so you can see like all three steps together, we get a core loop for an analyst who's working through a problem. I have an intention. It's like, this is what I want. This is the question that I want to answer. I have my human time that I spend getting to syntax. I have machine time getting from syntax to result. And then I have human time sort of spending time on the result and verifying that it's the right thing that I want. And getting through this loop quickly is really the name of the game for analytics productivity. And if we could do this quickly, then we could solve a lot of problems. A lot of people will say, hey, the machine time actually does matter. And I think that often we're just playing in different areas of this two-dimensional space of how often we spend writing new queries versus how often we spend executing new queries. And I think a lot of people will think about, like the query needs to be efficient, so it must be written in SQL. Well, that's people who want to work in the upper left-hand quadrant, where they want a mature data pipeline where it's very repeatable and reliable. I'm very interested in this bottom right-hand quadrant, where we're interactively working with data and reframing our questions on a regular basis in order to get the answer that we really want and verify that it's correct. And there might be two paths up into this like holy grail top quadrant where you're doing a lot of interactive work and also very fast and on the machine time. And I think, it's plausible that we'd start from interactive analytics and figure out how to scale something from there, rather than start with a really mature thing that answers one question well and expand the scope of it, say using like something like templates. All right, so I got a little recap where like there's the pro SQL side. I'm not even going to make the argument because everyone's already made it online and told me not to even give this talk. SQL is great, it's fast and scalable. The data I have are already easily queryable, and of course, everyone can already read and fix my SQL queries, which like I don't think that's actually true. You can see it's an anti-SQL point too. And also, people have figured out how to analyze funnels in SQL, so it's not impossible. But it's an awkward fit, and human time is important. And key to my point here is that if it takes a long time, we might not ever even do it. And there'll be questions that are left unanswered that are important for our business. And so just because something can be solved in SQL doesn't mean it's important to our business. And some things that are hard to solve in SQL might actually be very difficult. Well, it might actually be very important for what we need to learn. Okay, so next phase of the talk is how to not use SQL. And actually, I changed the name of this slide at the last minute to how to use not SQL, because I don't think it's about replacing SQL whole hog. I don't really ever want to claim that I'm going to invent a new query language that's better than SQL in all ways. There's no free lunch. But we need to think about building systems that are complementary to the expressive power of SQL in other ways, and that it will be a thing that extends our superpowers and gives us like ability to answer new questions, but can compose well with the SQL queries that we're already writing. So here's my rough diagram of an analytics data, like a whole data org end to end, from the raw data all the way to the things that users really care about. And I know a lot of people online will probably quibble about all the boxes and arrows here, but just all models are wrong. This one serves my purpose. And okay, so we got the stuff on the very far right. This is the impact that we're having from the data. And then we have the raw data all the way on the left. And any analysis that we do, anything that builds value is a path along this graph in some ways, including possibly loops where we do something more than once. So we could think about different roles here. Like here's an ML engineer who queries relational data with Python and then trains a model and then serves the model. And the model, drives impact by powering some beautiful new feature. We got the business analyst who queries the relational data that's already been turned into an OLAP cube with a BI tool, creates a plot, and convinces the CEO that they're going to do a bad course of action. Or the data engineer who is thinking about how are we going to extract and load the raw data and get it into the relational data, and how are we going to, run the pipelines, which are a batch of SQL queries that we're going to run on the relational data and continue to write new relational data into the relational data store. So everyone sort of has a place in this graph, and it's usually like a path through it that you are responsible for and that you think about. But the heart of the graph is the relational data. It's like, this is the heart of our organization. And I used to study social networks. We call this a position of brokerage in social networks. It means that to solve any problem, to communicate between any two nodes in this graph, it's very likely that you're going to have to go through the relational data. And so this is an important kind of like design consideration when you're building a new thing. It's like, if it doesn't read from and write to relational data, then it might be dead on arrival, like the query language that we built. So this is the inner loop, is a set of functions that we're going to run that consume relational data and emit relational data. And typically this is done with SQL or with Python and R in my experience, maybe less often. SQL is the most common case. Python and R can do this too. You can read from there's lots of connectors for databases, and then you can write back to the database, very common pattern at both of the companies that I work for, Lyft and Facebook. And one way that I like to think about this is that there's this abstract space of like relational data, and each of these operations that we're doing is like a path that we're creating between 2 points, where the starting point is what the data that we have, and the endpoint is the data that we'd like to have, which is like the answer to the question. And so by looping through this loop many, many times, we construct a path that gets us to the data that we want. So a chain of these operations is a solution to the problem that we're trying to solve when we're doing an analytics task. So how can we add a new functionality? How can we be more expressive than SQL? Well, we need to remove the SQL node and replace it with something else. And so here are 3 broad strategies. that I've seen in practice for doing this. And so the first one is kind of like the one that I already talked about, which is like taking the data, putting it in R or Python, working with it in pandas or dplyr, which know how to deal with relational data and can then like emit relational data. So this sort of like substitutes out a SQL execution environment for something else, but it still conforms to the interface that we care about. Then there's this like new breed of thing that I'm seeing, which is like to transpile a language into SQL. So Malloy does this and Prequel does this, which is like take a query that is easier to write in some language and make it into a SQL query that could be like a big, ginormous, thing that we're really worried about whether it's going to work, but it will because it's a transpiler and it can guarantee correctness. This is also an attractive strategy because you could add this expressivity, but get all the benefits of using SQL under the hood and using the same execution environment. And then what I'm going to talk about is actually this like convert it into a new space and then operate it within the new space and then convert it back into relational data. So we need two things. Is the box is a noun. It's a useful representation for the data that's not relational data. A converter to and from that thing, and then some expressive set of operations that work within that space. So here's my topological analysis of this is that we have relational data space on the left-hand side, and we have some alternative representation. And so this is how we do this. Is we have a round trip that we're going to take. This is difficult or expensive transformation that we'd like to make in space X, but that we can actually do in space Y under some sort of operations that we actually understand and are debuggable and are easy to express. And then we're going to round trip it back using the converter. So does this sound like a crazy idea? Actually, I think I've seen this play out in practice in kind of informal ways. And there's at least 4 different kinds of intermediate representations that I think make sense here. One is graphs. Graphs are sort of very hard to query in SQL, especially along paths. But if you convert something to a graph, it's very easy to think about how to solve graph query problems in some other way, say with a language like Cypher. And then you could convert a graph back to SQL quite easily because they're very easy to map back and forth. I've seen people use embeddings where you take individual rows or items within a SQL table and convert them into vector representation and then work with vectors. And then we could generalize vectors into like, some kind of tensor and work with tensors, and tensor operations are very easy to do on like say GPUs or in some area where you have better ability to execute the computation in a more efficient way. And tensors are very easy to map back and forth into the relational model. And then finally, you have like the heart and soul of motif is moving it into a sequence representation, operating on sequences directly, and then moving sequences back into the relational model when they need to be analyzed in a different way. And if this all sounds really crazy to you, I want to just like call out almost everybody who's watching this talk has done this mapping at some point in their lives. They have exported a CSV file from a database, worked with it in Excel, and uploaded it back into the database. You're using the design pattern that I'm proposing if you've done this. And I bet if there were a real audience here and you could all raise your hands, a lot of people would be raising them right now. This is the OG way of mapping something into a space where it's more malleable, the operations are easier to think about, and that you can be more productive. And think about what is the problem with this workflow? It's not Excel. It's that exporting CSVs and importing CSVs is a lossy converter. And if you had like lossless conversion, that actually this design pattern would be much more resilient than it really is in practice. I have 1 minute to wrap up. I just want to make the claim here. I love SQL. I'm not trying to tell you not to use it. I'm just saying that sometimes you maybe consider not using it when things are hard to do in SQL. And it comes from this kind of willingness to admit that you're going to iterate on solving a problem. I don't think that we write queries one time. They're usually like a malleable artifact that we're trying to nudge into the right state, and that we iterate as our business changes. And so expressive code and things that are able to express operations in a succinct way are very valuable, both for writing and for reading and understanding and reasoning about your system behavior. And so this expressiveness really matters. And choosing a good representation will actually make expressing the problem that you want to solve, the solution to the problem that you want to solve, a lot easier. And the way to integrate it with the way that we currently work is to think really hard about the interfaces. Don't reinvent nouns, reinvent verbs. And you can add one new noun if you want, but then at that point, you need to think only about verbs. And this has been a very productive way for me to think about the problem. And I've seen this design pattern in other places, like say in the tidyverse, where the type of data frame that we use has expanded in scope. over time. So I just want to kind of like encourage everybody to be a polyglot and think about new verbs. They can change the way you think about problems, and you might find that it's more productive and that you can still use SQL. It's always going to be there. All right. Thanks, everybody.